Good morning. I'm Chris Bidwell, recourse and complex networks. First of all, this is a little bit about who I am. So I'm a through-and-through geek, computer scientist, bit of a packet head. Did some software engineering in an earlier life, but technically I'm lapsed. I'm not allowed to call myself a developer anymore. I've spent the best part of the last 10 years doing networking for financial-oriented companies, so an investment bank and a services firm for a hedge fund. All views are expressed on my own, not those of my employer, because technically I don't have one anymore. So I'm quite pedantic. I like when things are just so, right? You get a piece of technology, the product sheet says it does one thing, I expect it to do what it says. In our organizations, we typically push the technology right to the limit, and so this is a real bugbear about the fact that few things actually live up to the expectation, right? So when it comes to designing networks for enterprises and specifically financials, I like to see that it's done right. You often don't get a second chance when it comes to executing trades for millions of dollars. So it's nice to know that somebody's put the time in advance. Stability is incredibly important in my world. This comment here about the demanding clients. When we talk about interruptions in a network, usually that would be for the likes of a small business. Maybe that's your internet's down for 15 minutes, a server's rebooted and you've got a 5-minute outage on maybe your storage or something like that. In our world, a drop packet is a problem. A drop packet is the difference between you executing your trade immediately or you having to wait for a round trip in order to identify that you've lost something. So we like stability. And there's obviously going to be a whole lot of 3-letter acronyms, so I apologise for that, but that's IT for you. So we'll cover some recommendations, which are basically best practices, things that I think are common sense, things that I think that people should generally be implementing as a default. Some of them are very basic, some of them might seem overkill. Hopefully something in this is obvious. Some of them maybe not so much, and maybe it doesn't apply in your industry, maybe it doesn't apply to your network. You have different design goals, and that's fine. We'll talk a little bit about, I've got some examples at the end, showing, a little bit toward what I consider to be hunting root cause for issues within an enterprise network. So, I dare say that you've all built networks, worked on networks, you've amended networks, troubleshot them, and I dare say that over time you've noticed that the documentation doesn't match what is actually out there in reality. You've got people deploying things like shadow IT solutions where somebody's dropped a little wireless access point on a desk maybe that you don't control anymore. You've obviously got a whole gamut of software evolution to worry about in terms of things change, you upgrade software, operating systems on devices, on servers, appliances, and a lot of these things, the point releases come out, and it's not like you have one point release that brings everything up to the same standard, right? You find that Microsoft patches on one day, Tuesday obviously, then you've got the likes of VMware or Cisco or whoever else it might be. They're deploying fixes for issues, but often these things are completely out of step with each other. People are deploying new features, and that doesn't necessarily all work well together, right? You sometimes find that these new experimental features or modifications all interact in a pretty wacky way. And if you're on the bleeding edge, often people haven't seen this before. There's no point going to Google. Google's only going to find it if somebody else has posted it. You've all seen those issues where you go to the forums and you found somebody's posted a question, no answers. Or the worst case, 5 years ago, somebody has the same problem that you did and then posts, it's okay, fixed it, never mind. Thank you very much. So I'd like to point out here, automation. People often sort of strive toward automation as a panacea, right? It's great if you can take all of your ops guys out of the loop, you deploy some scripts that are going to go ahead and make everything great, right? You put it out there, you've got nightly configuration backups maybe, you've got scripts that go around to maybe update documentation, for instance, switch port descriptions or to audit routing tables and keep track of things. What about when it all goes wrong? I like to think that automation just gives you the opportunity to fuck it all up faster. You know? So root cause, as far as I'm concerned, root cause is not just hunting the symptoms. It's not just fixing what the user complained about in the end case, right? So the network's slow, yeah. We've got issues with maybe you've got asymmetric routing in your environment. What's the real cause of it? What's the real cause of your performance issue when you have some software that's out of whack on one particular appliance compared with everything else, or you've got a user doing something particularly funky or insane? So trying to get to root cause is important for stability, or at least is it in my world, because I don't want to be doing the same thing twice. I want to fix a problem and know that it's gone. I don't want to run up against it in 2 weeks' time. I certainly don't want to run up against it in 2 years' time. So we like to make sure that things are fixed. To that end, I think it's essential to be multidisciplinary. By that I mean, it's not just important that you're a network guy that understands his specific area, but it's great to be able to cross over and understand how Linux works, how Windows works, how a file server works, into the likes of NASs from EMC or NetApp or things of that sort of nature. Some of the examples from other people's courses where they've talked about, for instance, step downs in bandwidth. You've got a 10 gig link here with a filer attached to it, you drop down to a 1 gig bottleneck, you're heading over the LTE connection to purloin some of Jesper's slides. In that sort of case, do people really understand what that technology is all the way along? I mean, evidently they didn't, right? Nobody really knew that there was, well, maybe they understood that there was this bottleneck, but not necessarily the impact of something like a driver. So it's quite important, essential, to know your environment. This helps when you're troubleshooting to be able to just jump in and identify whereabouts you expect an issue might be. If you already know that, for instance, you don't run RIP on your network, let's face it, who does? If you end up in a situation where you're looking at a packet capture and you see a bunch of RIP packets, why are they there? You know that they're out of order, you know that they shouldn't be there, so let's go and find what the cause of that sort of thing is. Now, admittedly, I've never had to troubleshoot a rogue RIP router on my network, but maybe that day will come. When troubleshooting and hunting for root cause, the stakeholders should be, well, everyone really, right? Everybody wants to see the performance go up. Everybody wants to see the errors go away. Everybody wants to save a little bit of money and time and effort. But what happens when those other guys just don't care? Or when they don't understand what the root of the problem is? We could talk for hours and hours about developers that develop software with absolutely no clue about the underpinning infrastructure. And then they deploy it and they think, great, again, the LTE driver, 4 meg window. Fantastic idea, right? Let's always keep the pipe full. But what about the rest of it? Let's think about all of the interactions and bear in mind that not everybody's at the same level. So a few recommendations. Let me set the scene as far as these are going to be, as I say, best practices and recommendations from the perspective that I see them in. And the goal here is to give you as much information, as much accurate information, hopefully in advance of an issue. But ultimately, when a problem arises, you don't want to be going back and retrofitting a lot of this stuff. In a lot of cases, you're going to have to, if on the back of this you decide to go back and implement some of these things, clearly that's a need. But in a greenfield site, maybe you want to consider some of these things from the outset. and make sure that you're designing with a fixable network in mind. So to that end, like good time. I don't mean punctuality, I don't mean turning up on time. I mean, let's have clocks across the estate, all of your equipment that actually match up. How many times do you log on to one router, you observe, for instance, a routing outage that's occurred on it, and you log on to the peer and you take a look at the logs on that and you think, these times just don't add up. I mean, maybe you're a few seconds out because you've got some hold timers to consider or something like that, but you should have pretty accurate time across your estate. To that end, the majority of people would use NTP. Now, out of interest, I assume you all run NTP and sync your devices to NTP. Is that right?
Yep.
How many sources do you use? 2? 3? Do you know what 3 gives you? 3 gives you the ability to identify that you have a false ticker in your network. It gives you the ability to identify that you have one clock that is talking garbage and that you've got 2 that are still okay, but you've got no redundancy. So I recommend that you pick 4. This gives you protection against that false ticker. You can go for PTP if that's your flavor of the month. Implementing PTP as precision time protocol. A lot more expensive to implement these days, but I dare say it'll get cheaper. And the important thing here is that you monitor this stuff. Go ahead.
Do you all strata stuff internal, or do you, one of those 4, will you go out and grab NIST or naval top board or whatever?
Good question. So, to be perfectly honest, it doesn't matter what you use so long as you are consistent. Okay? I mean, you need at least one authoritative time source, ideally something that's Stratum 1, i.e. it's syncing to some true authoritative source, either GPS or it's an atomic clock on the end of it if you've got that kind of money to spend. But, so in the environments that I work in, everything's hooked up to GPS clocks. So we have core sets of GPS clocks around the environment, and each of those should be pretty good. You know, there's an antenna on the roof of the building, and we've got authoritative time.
And all those clocks are internal, they're all inside your network.
They're all inside our network, yeah. So, then again, our network is a little bit of a different beast. There's very little external connectivity, and that's a whole different challenge in itself. But keeping things in sync, I mean, in that case, if you've got no communication with the outside world, you really need to take some authoritative source there, right? You don't want to be trusting the internal clock on a 3845 or some piece of junk like that. So be consistent across your estate and use a common set of time servers. If you have the money to spend on GPS clocks, buy a few, place them around the place, and sync everything to those. You know, you don't want to have all 4 GPS antennas on the same roof because you have one blackout in one area and you're screwed. So spread them around, sync to all of them, be consistent. Validate it, monitor it, and make sure that everything's as you expect. This mention about a grandmaster here is in specific relation to PTP, and that's a particularly interesting one at the moment because PTP is so relatively new that few people know how to look at it and inspect it and make sure that it's monitored correctly. There's tools for monitoring NTP, I dare say there are for PTP, but they're not as widely available. So think about it and keep an eye on it. This mention here of offset. When you're, this is specific to NTP. The way that NTP can compensate for latency on the network, right? It's built into the protocol. It understands that at a certain time, some timestamp was sent from another location. It needs to account for the round trip in order to remove that from the source of error, right? If you have asymmetric latencies on your path, this might show up as an offset. And in some cases, you'll be troubleshooting, why is this clock wrong? But actually, you've just got maybe equal cost multipath and one cable slightly longer than the other. Maybe you're routing through a data center you didn't expect, or somebody's been messing around where they shouldn't have been, or you have failed links. In our world, this often actually indicates that there's a provider issue. So we sync with clocks that are based off remote locations, and in these cases, where you have a leased line, maybe it's a protected service that's provided via SDH, In that case, maybe you're on one path for one transmission, and the return path is on the protection path. In that case, maybe those fibres take different routes. Well, they should, otherwise it's not much of a protection path. If the path lengths are significantly different, you're going to start to see offset on your NTP sources. And yes, this really happens, and we really get whinged at on a week-to-week basis when there's a subsea fibre cut out to Asia, and the market data team jumps up and goes, is there asymmetric routing somewhere? It's like, how the hell did you know? Logging, it's a de facto standard, right? Everybody wants to log. You should. You should definitely log, but you should centralise your log. Always pull it back somewhere where you can actually go through this stuff. There's no point having logs if you don't actually analyse them. It's great to have a couple of terabyte storage array where all of your logs go, but if you don't, say, archive them from time to time, your disk blows up, well, your logs are useless, aren't they? If you aren't checking that your logs are actually getting dumped to disk, you may well find you've got a problem when you need to actually look at something. I recommend here that you log timestamps on your logs. So normally what we do in our network is that we'll log a timestamp 2 millisecond precision on, say, a router out in a remote location. We'll also log at the same time when it actually arrives at the syslog server. Now this gives us two useful pieces of information. Number one, it lets us identify that the clocks are actually pretty close together. Maybe the logs are going to be a little bit out because you've got a round trip in there. That's sort of to be expected. Maybe you've got some processing time on one of the hosts that's going to cause you some offset there. But important that you actually know where that log was collected and what the timestamp was at the time that the log was sent. It's no use to be a few seconds out when you're troubleshooting an issue that occurred in less than a second. Keep all your stuff, retain it, yada yada yada, and don't forget, syslog is usually UDP. You can go ahead and configure TCP for protection on it, but what happens to UDP when you've got an outage? Is there a retransmission? No. Your logs come out to say that you've had a routing outage. You're pretty lucky if your log server was actually on the other end of that path that you had the routing outage occur. If your reconvergence isn't very quick on the LAN, you're probably not going to see that message. So it's a good idea to have a couple of central locations and be prepared when you're troubleshooting to check all the logs. Don't forget to go out to the device. Don't forget to check the central stuff. To go along with logging, and you may use SNMP to trap some of your logs. In my world, SNMP is used primarily for polling devices. Go out there, trawl it, pull back all of the information that we can. Polling intervals, there are a lot of recommendations, and a lot of tools will default to, for instance, polling interface counters on a 5-minute basis. I've just said, you can't troubleshoot a 1-second issue when your logs are 5 seconds out. How are you going to do that when how are you going to troubleshoot an issue with a microburst, something that occurs in maybe milliseconds, blasts all the bandwidth away on that link, and causes some kind of issue somewhere? How are you going to detect that if you're only polling at 5 minutes? 1 minute here I say is aggressive, but that's about as far as you can usually push this stuff. Most things, when you start to scale out a large network, you can't sustain a rate. In fact, in our network, it's pretty difficult for us to sustain a rate of 1 minute polling averages. But to do it for anything more granular is often pushing the bounds. So I'm not saying that SNMP polling is the panacea of what you want to be doing in terms of collecting your statistics. Clearly, you want high granularity bandwidth utilization, you're going to need to go to packets. Ideally, you're going to tap and what have you, we'll get to that. But in this case, 1 minute is necessary. Don't underestimate the value of it. When you're trawling all of this sort of information, has everybody done an SNMP walk of a device at some point in time? Yeah? So you get loads and loads of numbers, or if you've run it just with defaults, then you end up with all of the OIDs being converted to their native format and with the names included. but there's tons and tons and tons of numbers get kicked out of the back of them. Stitching these things together is not always trivial, but there's usually pretty much everything on the devices there. So, for instance, hardware inventory, what the model of the device is, what the models of the transceivers that you have installed in the device, what the serial numbers for those are. Sometimes you'll get power readings. You'll get your transmission stats, including your in and out packets, bits, yada yada yada. But all of this stuff is useful and should probably be tracked over time. Now, it might not change. Transceivers, for instance, you're not going around and swapping them every couple of days, but every now and again you'll have a failure, you'll change one, and it will matter to track where that serial number ended up. How many times does you send out a cabling guy to go and do the actual swap if you're lucky enough to be a big organisation where you don't have to touch stuff anymore? If you send out the cabling guy to go and retrieve that transceiver, does he know the value of the transceiver, the value of knowing that that may be faulty and that it may need to go for fault analysis? Does it just go back in the bucket? If it goes back in the bucket and it had an issue and it ends up back in the network later, it's a good idea to be able to stitch that together and identify that you really did have a problem with that transceiver, when it was, get rid of the thing. I mentioned here tracking Mac, ARP, routing and Ceph, etc. Ceph obviously Cisco. All of these are dynamic. Well, unless obviously you're static routing, but let's face it, everybody's dynamic, right? So your MAC tables, your ARP tables, your routing tables. If one of those things changes from one day to the next, do you know? Do you know what MAC address your storage filer has? And if you have a rogue device comes along, and it was mentioned in somebody else's talk, rogue device comes along, hijacks another MAC address. Have you got any idea where that MAC address came from? Well, if you log stuff, if you archive all of this, maybe you'll have a chance. And this comes in real handy for identifying, devices that move around, even loops and suboptimal switching.
Chris, before you leave that,
Yep.
The idea of securing all this data, so, or all number of these sessions and the risk, and so is that starting to enter into your world? We've got all this critical infrastructure information, and when do you start parking firewalls or some kind of security mechanisms to protect this kind of?
So with regard to the SNMP, for instance, in our world, it's all read-only. You never get write access. There's never any ability to write to any of these devices unless somebody screwed up and misconfigured it. But and in those cases, and we should be pushing for authorized SNMP, but to be perfectly honest, it's too much work to go back and retrofit in one hit. We still need everything to work, and there are various compatibility issues with some things. Now, it's been around for a long time, SNMP v3, but in my world, I don't do it. In an ideal world, I would definitely do it, but then I'd have time to set it up and make sure it works and test it. So, in terms of storing the values afterwards, everything's internal, it's considered private, so the statistics that come back are pretty meaningless to anybody else, hopefully. In terms of device configuration, something else that changes over time. How do you know who made a configuration change? Real-time change detection that I mentioned here, RTCD, it's an acronym I stole from a product somewhere. And nightly downloads are pretty crucial to certainly to my world in terms of identifying what changed on the network. That's the first thing you ask, right? When something's gone wrong, and you're like, okay, who changed it? What's going on? Being able to pin it back to somebody, not necessarily to blame them, but to identify what the rationale was, why it changed in that way. That's pretty useful. And tracking this over time is essential. There was the mention from John about your router. You make a BGP change 2.5 years ago, everything's fine, the neighbourship was still up. It's all good until there's a power cut, comes back up, what the hell did I do to this? And why? When? So backing up all your stuff like this is quite important. I built a tool to automate the process of auditing these things, whereby we'll generate config differences and then tally it up with the likes of TACAX command accounting, to pin it on someone, identify what commands they executed, and to be able to come back to them and say, why'd you type that? As an example of one of my bugbears with configuration changes and people tracking configuration changes, many tools they come with device templates. They know how to interact with the device. They know how to go out there and run a show run, or if it's a Juniper, whatever the command might be for that. In the case of Cisco ASA, and I checked a couple of weeks ago, and this was still valid at this time, there's a tool whose vendor will remain nameless, whose default configuration for a Cisco ASA to retrieve the running configurations, to log on interactively and do a show running config. The problem with the show running config on an ASA is that some bright spark said, we shouldn't be dumping things like SNMP community strings when any old administrator can run a show running config. We shouldn't be dumping the pre-share keys for VPNs. We should mask those out. So you get a bunch of asterisks that appear out there. Somebody naively, somebody in the back, is maybe duplicating a device. They're replacing something. You get into the habit. You log onto a Cisco IOS switch. You show run, dump it to a text file, copy and paste it into the new device. If you do that on an ASA, you might well find that your VPNs don't work anymore, unless you happen to have a pre-share key that was 5 asterisks. You spot the difference? So, if you are running configuration management tools, go and check that when you actually pull a configuration back, you can restore from it. What's the point in having it if you can't do anything to get back to where you were? And sorry to anyone from Cisco or anyone else. In terms of extending the configuration, the dynamic state, and I mentioned about interface utilization or bandwidth utilization, capturing packets, ultimately, I mean, that's what I get off on. I like knowing that I've got everything and I can wind back the clock and have at least a few hours worth of data to go back to. Personally, I capture everything. I mean, yeah, okay, I'm certainly overflowing my output interfaces if it's a span. I don't have the luxury of being able to tap every link. I certainly don't have the capacity to store the output from a tap of every link. And I'm not too concerned about the exact timing. I mentioned here the sources of error introduced by whatever you're going to do to capture your traffic. Okay. Now, sure, I'll hold my hands up. Taps are, the best way that you're going to get an authoritative source of the traffic that you're going to capture. But in a world where microseconds count and increasingly caring about nanoseconds, have you considered the length of your cable? Have you considered the impact of installing a tap in the link? I mean, you're physically connecting another device in the middle of a link, right? Unless it's an optical tap, which is the lowest impact as far as you're going to see, you actually introduce some latency onto the link by installing a tap. Knowing what that latency is pretty important if you're dealing with the likes of matching trades and knowing that you were the quickest guy on the block. If you have introduced 4 taps along the path to identify exactly what's going on between each router, and if you have 4 routers on an algorithmic trading flow, you're probably nuts anyway, but if you've got 4 taps on that path, you've got 4 times the latency impact that you've got from passing through those ports, and it might not be that much, but to the guy who's directly attached with fibre, as opposed to going through 4 copper taps, I know who I put my money with. Augmenting the capture data that you have, I think NetFlow, SFlow, IPFix, etc. really useful protocols, but they don't tell the whole story. Often they're sampled. Some devices kick out junk. Some devices give you much more information that's much more useful in terms of giving you visibility into what flags were set on packets. But the consistency isn't really there. I dare say anybody's configured NetFlow, you log onto a device and okay, what am I going to go for? V5, V7, V9? What's the difference? What about those devices that don't support the older versions? If if you've got some older kit that's only supporting NetFlow v5 compared with a brand new device that only supports flexible NetFlow v9, do those two traffic flows look identical? Maybe. Maybe they don't. Maybe they report at different intervals. Maybe you didn't set up your exports correctly. But spotting that kind of thing is often quite difficult, and so combining lots and lots of sources of data like this, and preferably something authoritative like packet data, pretty important. As I say, I acknowledge the inaccuracy in our capture plan. You know, I know that we don't have everything. I know that it's not authoritative time. It's as close as I'm going to get. I'm just really grateful for the insight, to be perfectly honest with you. And I know that most of the day we're not maxing out our links. But in those cases where I go to look at something and I spot, okay, this was at line rate for some time, I appreciate that. I probably dropped something on the way to the monitoring. Just be cognizant of what you've got in your environment, how it's set up, and how you go about interpreting that data and recognizing where you may have lost something or definitely lost something. Little mention down here for Loris's new venture, Sysdig. Basically brings a lot of this PCAP type functionality to capturing host level events, which you might find quite interesting. He did a good talk last year on it. Check it out. When I'm deploying a network, I set out with a goal. I know what I want to get to. I might have 2 links that I need to implement and they need to be resilient. I might need to know that the failover is going to occur in less than a second should one of the links fail, ideally a lot quicker. But unless I go ahead and test this properly when I'm deploying things, I'm not going to know for sure that really happens. Again, we can hark back to lots of other presentations where people say, you know, go back and actually check that your redundancy works. Yank a cable, pull something out and see what happens. But don't just do that. Don't just do the obvious. Don't just test for the things that you know are going to fail. Get somebody to go and randomly break something. Have them fill something. Go and knock a cable. Go and brush some fiber and see what happens when you actually look at the outcome. I mean, obviously don't do it in your prod environment unless you've got very, very big bulbs. But understand what the impact of these things are. Not everything fails in the same way. Baselining your setup is something that helps here immeasurably in terms of knowing how this sort of thing behaves under normal conditions, right? If you don't know what your network looks like on a normal day, how do you identify what's broken when you've had a bad day? Go and take a look. Prove your tools work before you need them. There's countless cases of people will have an issue, go out and buy a tool to fix a problem. But what about the fact that you may need some historic data to compare all this to? If you've never checked that your tools really do what you think they do, and you rely on them in an incident, well, good luck. You might be doing a lot of reading or backpedaling once you've pushed out an explanation that doesn't really make sense anymore. And I'll just say it, check for regression. Check that you haven't regressed any actual features that you deployed. I'll show you an example later where something grew genetically over time. It was a piece of infrastructure that's supposed to be simple. But we introduced various levels of redundancy over time, and eventually we regressed some behavior, and that caused us some headaches.
Question for baselining?
Yeah.
Products, perhaps you would recommend, or
Wireshark.
Okay.
Yeah, that's what I go to. I tend to, I'll fire up Wireshark on my machine, have a look at what's going on, I'm nosy. I take a look at what's going on and spot the unexpected type stuff, or the stuff that makes me think, I wonder why that's happening. I use that a lot. If you're setting up an environment for the first time, if, for instance, deploying a co-location setup somewhere, so in a stock exchange in my world, we often have permanent capture for some components of it, but it's really useful to have some host there that you can steal for a while, permanently dump some data to for the first couple of weeks of deployment, and just go and take a look every now and again, in hours, out of hours, what's going on. You don't need to have a look at, every single packet, but just scan through it.
So, Wireshark analysis to make sure your routing, to make sure your topology is operating as designed versus application performance. So you're not on the hook for baselining financial applications, you're on the hook for your infrastructure.
Correct. Because often people don't engage us before they deploy anything, right? So if they talk to us first, sure, we'll help you. But unless we know that a new application's coming along, it's pretty difficult to sort of proactively spot that. Now, there are ways and means of doing this, and certain vendors, heuristic-based and learning-based appliances that sit out there, watch the traffic that's occurring and spot anomalies. It's useful to deploy some of those things, but you've got to invest the time to make sure it's set up.
So just one last question.
Sure.
So, but when is that not good enough? So we're network engineers. We're building up topologies that work and function 100%, right?
Yep.
And then we're on the hook when some application fails, and it's like, look, guys, in an enterprise, I'm the network guy.
Yep.
I'm the topology guy. So when is Wireshark and network engineers either completely on the hook for application analysis, or are there other teams? So in your environment, right, when you step into those environments, is there another whole bunch of coin that's dedicated to application analysis, and those guys, no. So there's one syslog, there's one paradigm for all this analysis, but it's not the application. It's not geared for application analysis. So when is that simply not good enough?
Well, all the time, to be perfectly honest.
But doesn't that beg the question philosophically? Then is it valid?
Yeah, I totally take your point. And there are people that I've spoken to who, in very mature organisations, where they've already been through this pain several times, and big people have noticed. People with the power to spend money have noticed these problems and said, okay, you guys need to look at this before you deploy. In those sorts of cases, you often find that there are some application performance engineers, but network engineers, but geared toward helping educate users and developers to make sure that they're deploying in the right sort of way. So examples would be implementing TCP keep alive for sockets that persist through a firewall over time. You clashes with session timeouts versus how chatty an application might be. Some of these things are very, very simple fixes, but the developers just don't know about them. Right? So, in an ideal world, and where I'd like to get to, every new application that will come online would spend some time with baseline it and move on and make sure that we know what it looks like. But yeah, it's difficult, and there's no quick fix. You need to spend money and time. So as far as some underpinnings, I'll rush through these because they're not very interesting, but I said that it's important to understand sort of the different failure domains, how a particular connection might fail in terms of, you have different issues with a copper connection as you do with a fiber connection, and completely different issues when it comes to RF. So, understand the media that you're actually going across and be aware of the sort of issues that come along with those things. Don't just casually assume that, well, okay, my link has gone hard down, so, well, this must mean that somebody's jacked out the link on the other end, or somebody's cut it. If it's an optical link, maybe somebody's bent a fibre somewhere and you've just lost light in one direction. The other end might actually still see link. So in these cases, there's an application or protocols you can deploy on top of some of these things to help out. The UDLD would be an example of this sort of thing. But be aware that there's a physical media that underpins this stuff. It's not always a protocol. It's not always the software. It's not always your shit.
Well, and you want to validate this early because we assume it's always going to be working.
Right.
And so that's the easy one to try to pull off the table. Then you go troubleshoot the higher stuff.
So take it back to when I said about collecting everything, inventories that you pull off a device. If you can go ahead and pull your, for instance, for optical links, pull your light levels, track them over time, spot a failing transceiver, hopefully before it causes you issues. But on those days when you actually have an issue, and you identify that you've got either a failed transceiver or a dirty fiber link somewhere, can you pin it back to a particular time when that transceiver started reporting low light. I mean, you're not going to get this from all kit, so push for the enterprise stuff if you can, but pull everything. Always track it. Yes?
Another thing is understanding not just what could go wrong, but that like on a submarine case, particularly when you're dealing with financials, if the cable is cut and replaced,
Yep.
it doesn't have the same weight.
Yep.
It never comes back with the same weight.
The ship goes out, pulls it up, finds some slack, chops it back together again, and yeah. So the comment there was understanding that that there's physical, well, there's a logical impact on the top of physical changes involving when something fails, for instance, a submarine fibre cut, and these things don't get fixed overnight. It takes a couple of weeks normally to dispatch a cable ship to the right location once they've figured out where the issue is. Then they've got to pull it up, they've got to splice it, test it and put it back. It could be months. In fact, we're probably still in the environment that I work in, or used to work in, probably still waiting for some submarine fibre cuts to be fixed that started at the beginning of the year. You have op-amp failures. Like, what? It's not my world, Let's get out of that. Layer 2 and Layer 3 foundations. I mentioned MAC and ARP. Other dynamic protocols that sit there on your network and influence behavior. DHCP, the likes of NAT. DHCP in particular. Anybody ever had a rogue DHCP server turn up on the network?
No.
Yeah. And the issue there is usually it shows up on a local subnet and it starts polluting that local subnet. It often won't get any further, but you've got a group of users that are all complaining that suddenly I can't get on the internet. Okay, I can't get at your machine anymore. You seem to be on a completely different network. In those cases, if you're not monitoring for these things, if you're not tracking state, if you're not understanding that these things can change without anybody physically interacting with it or without anybody that's authorized physically interacting with it or reconfiguring things, you're going to have a bad day if you don't appreciate that some of these things will take over. So remember to go back and look at these things. Spanning tree. Spanning tree is a beast in terms of keeping an eye on what has changed. If you don't set up your route properly to begin with, if you grow your network and you don't take account of that sort of thing, you rely on some people will take a bunch of switches, build a network and rely on the fact that this one has a lower MAC address or a higher MAC address, whichever one wins, and rely on knowing that will become the route. What about if you have a hardware swap out and the MAC address changes? Track some of these things and think about them. I'll move on from there, unless anybody has a specific interest in any of those, but skip through. From one of my favourite topics is how the hardware works underneath. So I like to know that the box that I'm dealing with is behaving the way that I expect, and that comes often down to things like CAM and TCAM resources, understanding clocking rates within the devices, understanding the ASIC layout on a switch, for instance, or whether or not you've got any kind of virtualization going on there. The likes of the Nexus stuff from Cisco came along and gave us all VDCs, and that's wonderful, right? You can carve up your switch and run multiple switches within a single switch, but you are resource sharing, that you are splitting your time everywhere, and that's fine in the cases where you want to increase your efficiency in terms of OpEx, because you don't want to spend more money on the kit, and you want to get the most out of it. But if you're relying on this thing to deliver peak performance every time, well, maybe you're not going to if you're sharing resources with a whole bunch of things. Consider that, and don't let people push you around in terms of we'll run the backup link as well, active. One day the shit's going to hit the fan, and you're going to regret that. Get somebody to sign off on it if you're going to be bullied on it. Somebody with some clout. Mentioned different failure modes, things breaking in new and interesting ways. In terms of WAN connectivity, a lot of this stuff, and a lot of it's hidden from you. So we buy leased lines in our world. We buy connectivity, dedicated bandwidth. In a lot of cases, you have no idea how the provider is really providing that. I buy a layer 2 pipe and I expect a piece of fibre shows up on site and far as I know, it's a wave. No, maybe it's over MPLS. And that causes issues if you don't understand that there is a justification as to why you might have an issue on that link without seeing a physical change in the line protocol, for instance, or rather the link level. So if your a path changes with an MPLS network, your link doesn't usually go down unless something's configured carefully for loss forwarding. So in those cases, a lot of things can change without any kind of indication. So some more dynamic stuff and devices that introduce all kinds of headaches, wins. Admittedly, I haven't had this issue for a few years, but DNS, people go to ping a host and say, I can't ping this machine anymore. And not understanding, what the difference between a DNS lookup is and a WINS lookup, and maybe there's some device there that's spitting out garbage data. It wasn't supposed to be connected to the network anymore. It's not supposed to be running WINS. But by default, Windows is picking up those responses if it's quicker than DNS. You fire out a lookup to both WINS and DNS at the same time in some configurations. Maybe your DNS servers aren't working, and now you're relying on some garbage WINS data. God help you if you're still running NIS. Logging and audit should be a core feature of all of these devices, especially when it comes to security, right? You want to know that something changed, that it was an authorized person that did it. So again, combine that with your logging infrastructure, combine it with, if you can correlate things like TACAX accounting or radius counting, your LDAP and things, combine all those sources of information and understand how your networks work. Common causes for application latency, high RTT, the number of times that you have users on the other end of the world suddenly start using a new application because somebody said, oh, we'll shut down the local instance, we've already got one over, say, in Hong Kong, we'll use that instance, it's much cheaper to run it. Suddenly performance goes to hell. Happened a couple of times to you guys? Yeah.
No.
Yeah, no. So think about these things. Bear in mind that loss has an impact on these, especially high latency connections. Out of order packets, not supposed to cause an issue, but it can. Depends how fast you're running, how quick your networks run, how hungry your hosts are for the data, and how well configured they are. Obviously, crappy code, my number one bugbear. So some tools to help you out in your day job, I suppose. And these are for you, right? Tools it's your tool set. It's for you to help you do your job. There's nobody's going to say this is the correct tool for the job. Sometimes there's a whole raft of them. Pick the one that works for you. Spend some time to make sure you understand it, to customize it, to make it easy to use. Understand the shortcuts that are there or the limitations, especially understand the limitations. And be prepared to go out of your comfort zone every now and again if there's another tool that does something better. And to that end, keep some cheat sheets if you need to. There's no shame in having a regex cheat sheet stapled by your desk, or a quick BGP command summary, or for instance the path selection algorithm for BGP. Nobody's expecting you to keep all this stuff in your head all the time, and maybe it will save you the day that the internet connection goes down and you can't get to Google to check what it is. So maybe print a couple of things out, unless you've got a paperless office. So some tools that I use or I'm aware of here, I'm not going to talk through it, take a second to take a look. I don't endorse any of these things.
What do you use for your syslog?
So literally a couple of Linux machines running rsyslog-d, so old software that's very stable, very solid.
You're not using Splunk or Elasticsearch?
So we have that in some areas of the organisation, and they are being used. But for what I need, I'm not particularly interested in that. I'd rather have access to all the process, like I like to see it, much like a packet. But yes, something like a seam solution or some aggregation tool like that will often be very, very helpful to cut down on false positives and help you identify, well, reduce the redundancy in terms of duplicate alerts that we receive for something. That's a major headache in some cases. But no, I don't personally make use of the likes of Splunk. So, every now and again, we're going to have a bad day. Who knows what it's going to be? Normally it's a combination of factors, and usually it's this bottom one that's the catalyst. No idea why, but you know, when payday's coming around maybe, or financial year ends up, and suddenly everything starts creaking, you're going to have a bad day, right? So it's not always some individual thing that really pushed you over the edge. There's lots and lots of things normally that are brewing, unless you're in a very, very well audited, well baselined and maintained network, which, let's face it, is pretty rare. So just be cognizant of the fact that there are lots and lots of things that will add to make your day really shitty. When an issue actually gets reported to you, and you start to take a look, I mean, let's say that user picks up the phone, my application is performing slowly. I try to load this web page, and it sits there, it just does nothing. The network must be broken. Okay, well, maybe it is, maybe it isn't. Maybe there's something else going on. Maybe there's a fat finger involved. Who knows what's going to go on? Keep your cool and be aware of your environment when you're troubleshooting in these sorts of situations. Make sure you take the time to speak to the user, to reiterate the fault to them until you both understand they're on the same page. Be aware of what is going on around you. I'd say it's a line I stole from House. Patients always lie. Nobody tells the truth first time. It's not necessarily their fault. Maybe they're just not talking in the same language as we are. To some people, a frame is one thing and a packet is something completely different. To some people, they're synonymous. If you're not talking with the same vocabulary as your users that are complaining to you, and you're hunting an issue, and you're a particularly technical kind of person, maybe that's going to lead you down an incorrect path. Maybe you're going to spend a lot of time hunting something that you just don't need to. Maybe the issue really is that the user's clock's wrong, or they've plugged it and they've created a leak on their local network. Maybe they are just having a bad day. They think it's slow, but really, you go to the application performance management tools and say, actually no, nothing's changed. Round trip's the same, application performance is the same, server response time's the same. Maybe you're just grumpy today. Be aware of this sort of thing, and don't end up down the rabbit hole. Back out, take a look from a higher level, be aware of everything that's around you, and remember that not all problems that you see are actually problems. In the case where you're going and baselining something, you're going and taking a look at the packets that you see on your network, there's some stuff there that's going to look like garbage, especially if it's the first time you've seen a new application or even a really old application that's running on your network. Just because it's there doesn't mean it's an issue. Just because you have asymmetric routing doesn't mean you necessarily have a problem. Just be careful when you actually go through these steps of not pinning things too quickly on what you think the issue might be. And bear in mind that organisational factors often play a part here. So again, back to things like end of month processing and payday and things like that. People get a lot more stressed, or maybe just after payday, people are spending a lot more time on YouTube and your internet connection's a little bit slower. There's all kinds of things that may be, just from a people perspective, affecting your ability to take a good look at the problem. Maybe the reason that nobody's reporting any issues yesterday was that everyone was on a holiday. Maybe it did break at the weekend and nobody was in on Monday to complain, but Tuesday, suddenly all the alarm bells start ringing. Bear in mind that there are things such as, days off, occasionally public holidays. I like to make sure that when I take a look through an issue and for instance, I'm troubleshooting something from end to end, that I remember to go through and check all of these things individually, you know, making sure that where you've gone through the likes of a equal cost multipath, either routed layer 3 or you've got maybe an ether channel where you've bundled lots of links to provide yourself a lot of redundancy. Well, maybe one of those links underneath the channel has got a bad, dirty connection. I think somebody brought it up the other day. There's some users are working fine, and some users are absolutely terrible performance. But it should be the same for everyone, right? Everyone's going over the same path. Everything's fine at a high level. I sit there and test it. It looks great, but I'm getting hashed onto one particular link out of one of the bundles. Maybe link 3 has got an issue. It's got some packet loss on it, faulty connector. Remember to take a look at the basics, including your forwarding tables. Bear in mind things like Ceph doesn't necessarily follow the exact same path as what you might expect from looking at the routing table. There are lots of variations. There are lots of reasons why you might not be doing what you expect. So remember to take a look at all of your options. Don't just focus on the most common one. Don't do a trace route and think that that is the only path. If you use equal cost multipath, you might find that the second time you run the trace route, it takes a completely different route. Remember that it's not necessarily the same path on the way back. Go both directions. And bear in mind that there's always a security device somewhere around there that's going to be taking care of some of your issues. Either filtering some traffic out or changing the addresses in there. Perhaps that's the reason why you can't stitch together some conversation. Or you've maybe an MTU issue because you've got tunneling in your environment. Maybe it's over a backup path that you don't normally use and you haven't seen this because you haven't hit the failure scenario yet. Be aware of it all, if you can. So when you've troubleshot an issue or you think you've got to the point where you've identified what the cause of it might be, well, take a look at it and rationally apply the logic again. Walk through it. Let's make sure that you don't go back to your boss and go, it's definitely the database guys, especially if he's a database guy himself. If in fact, you haven't checked some underpinning things, maybe it's DNS. That's the problem. Just throwing applications and protocols out there may be an issue to you because they have very, very complex interactions normally. For instance, one of the first issues that I worked on when I joined a bank was dealing with some Unix administrators who were complaining that one of their hosts must be on a bad connection because they try to log onto the machine, they get a prompt, but it takes like 30 seconds before they get prompted for the password after they've supplied their username. Taking a look at the host themselves, they couldn't identify what the issue was, and they should have been able to identify what the issue was. They've been doing it a little while by this point, and it turned out that there was a DNS failure. They were trying to log on to this Unix machine. It was doing a reverse lookup on the source of the connection, failed the DNS lookup because of a bad configuration, somebody fat-fingered a DNS server. And as a result, it sat there and waited 30 seconds before it timed out on the DNS request, before it prompted for the password to authenticate the user. In those cases, you might take a look at that and say, well, ping's fine. It must be that box. Well, maybe actually they didn't fat finger the DNS server. Maybe a DNS server really is screwed. Maybe there's a filter in the way that is stopping you accessing that DNS server. Unless you take a look outside of what you've identified and test that theory, actually implement it yourself. Go through the steps of, okay, I'll initiate the connection. I can do a telnet. I can do a telnet and see that an IP layer, I've got connectivity, and that's fine. But that doesn't help you necessarily pin the blame fairly on where the issue is. And don't just naively assume that it's the end user that doesn't know what they're doing. It might well be your fault once in a while. And to that end, double check. don't rely on the first thing you write down, especially if you're dealing with the user query. You know, they call up, they give you an IP address, they're rattling it. You know, you're rattling it down on a piece of paper. Maybe your 7 looks like a 1. Maybe you forget to go back and double check all of these sorts of things. Everything should be double checked. And in the case, I'm very lucky. I have some excellent colleagues that I can bounce these sorts of things off. It's really good to get some feedback, particularly to have somebody argue with you and say why. If you can't explain to them why your theory makes sense, maybe your theory is garbage. I mean, maybe they don't know what they're talking about either, but at least if you can go to the nth degree and explain it, draw it out, you get a much better understanding and confidence in yourself that you've really tracked what that issue might be. The only thing that I really want to focus on here, beside the timeline, understanding exactly what occurred on the in terms of the issue, is this. Try to keep friends. It helps when you can still talk to the guy on the other end of the phone, like after you've finished bitching him out to his boss. You know, it's important to maintain a healthy working environment. To that end, line up the fixes, help them to actually do, you know, what needs to be done to resolve these things. There's no point in just going back and saying, yeah, the application's shit. But if you know something about it that you can help them. Foster the relationship, educate them, improve your life by stopping this happening the next time. Hopefully they'll go and tell their friends, colleagues. So, a few minutes left to go. I'll go through a couple of examples that I have. I apologise that there's going to be no traces in my environment. I can't get traces out of the place for obvious reasons. My pictures aren't pretty. There'll be some words. So, this particular issue that I came up against a few years ago, and I have to say, hold my hands up, I caused it. It was my problem. My problem was the one that actually pushed everything over the edge and started really bringing this issue to the surface. The root cause, technically not my fault, but I certainly contributed. So we had some network maintenance one weekend, and we were upgrading some core devices, and in our world we use a lot of link level encryption devices to ensure that our data is private and secure from one end to the other. We were deploying, taking an opportunistic approach to go ahead and deploy firmware upgrade. We'd already got permission to take down the whole network. We may as well take down all the other links at the same time. So we went ahead and we upgraded the code on our encryptors. We'd already been running it in the lab for a little while. It was looking good. Turns out the kit in the lab wasn't exactly the same as what's everywhere else in the network. And this comes back to understanding what's under the hood. But around about the same time, we've been going through a rollout. People were migrating from Windows 2003 to Windows 2008. Servers were being swapped over piecemeal. And this was just, it's happening, another team is dealing with this. They're getting through their own objectives, they're deploying it onto, servers that they think are important first. They've gone through their level of testing, but most of it's in a LAN type lab environment, not over a WAN. So we come back in after the weekend, after all this maintenance, and we're starting getting complaints from people that this transfer from this one data center to the other is taking so much longer than it used to. It's like the performance is terrible. 1 gig bottleneck, and there was no step down anywhere else. There's no other checkpoints. The one thing that I would say is that the 2K8 boxes that were being deployed with 10 gig NICs. And it contributed for sure, but it wasn't ultimately the source of the problem. It wasn't a buffer bloat issue that caused our problems. The round trip was reasonably low. I mean, normally for us, sub-millisecond is what we'd like to see in our environment. It was a few miles away. It was 3 milliseconds round trip, but we were obtaining a throughput speed of only about 5 megabits a second, and the hosts that were affected seemed completely random. There was no rhyme or reason except for the fact that they were 2K8 standard edition. When we took a look at the issue and started to diagnose it, we quickly realised there's no way to find any commonality other than the operating system on these boxes. But different roles, file servers, some VDI kit, all kinds of things showing problems all over the place. But only certain interactions. It wasn't 2K8 to, for instance, 2K3 specific. It tended to be, there were a combination of OSs that were causing issues when talking together, and we really struggled to pin it down. So we deploy our captures everywhere, we take a look at the packets, we did some flow analysis to make sure that we understood that the path that was taken really was the path that was supposed to be taken. And it ended up coming down to us identifying that, the problem that I'd introduced was I'd introduced this code onto the encryption devices, which was supposed to give us improved performance by spreading the load across multiple cores on the CPU. We had these 2K8 boxes which had been deployed where the MTUs hadn't been adjusted to account for the fact that we had encapsulation on the network. We didn't do any MSS rewrite. So the boxes are sending out larger packets than the encryption device is prepared to handle. Fragmentation is required. These boxes don't care about your DF bit. They will go ahead and crunch your packet down into as many fragments as it needs to get it through its pipe, because it's supposed to be completely transparent. Unfortunately, that meant that what you had was one large packet entered one core and one small packet entered the next core. And because of the laws of physics in terms of the encryption that was going on, the small packet got encrypted quicker and exited the device before the big packet. So out of order packets introduced straight away, and we were relying on the host at the other end to reassemble, by the way. It wasn't being done by the encryption device in the middle. So we acknowledged that we had some out of order packets being introduced, but again, you look at this and you think, well, why is that an issue? Everybody tells you that TCP is able to recover from this sort of thing. TCP is able to cope with some out of order packets, and it is. It dealt with it. I mean, we still sustained 5 megabits a second of throughput. It wasn't completely dead, but the performance was much lower than what we'd have expected when we took a look at it. Turned out, these 2K8 standard boxes, standard edition, they decided that they would, it was a 64-bit architecture, they decided that there would be a limitation on the amount of physical RAM you could address, 32 gig in standard edition. The boxes that we were buying for these, some of them were being bought, they had a base configuration of 8 gig of RAM. And then we bought an extra 32 gig of RAM and had somebody else build the physical machine to populate the RAM. In the cases where with, some of the engineers that were doing this build, and it was a supplier, some of them were like, well, we'll leave the 8 gig in, you get 8 gig for free, okay? So these boxes are turning up with 40 gig of RAM installed, but the operating system can only address 32 gig. No problem. Except that 2K Standard Edition, too much RAM in this box actually breaks a surprisingly large number of features, including selective acknowledgement, which was supposed to be taking care of the fact that we had some loss occurring on the network or out of order packets. Selective acknowledgement just did not work. It ignored the packet, and so we were relying on a full round, the retransmission timeout to deal with then the ACK to trigger the retransmission. We weren't relying on the SAC, although we should have been, and unfortunately in this case, it was, as I say, my change that broke the camel's back. I'm the one that got pinned for it, but ultimately, something as simple as somebody leaving an extra stick of RAM in a box that you can't even see from the operating system. How do you identify that sort of thing? That took us a long time to get to. So, a quick question for the last couple of minutes. So, how many ARPs per minute do you expect on a LAN? Say again? Well, so yeah, it depends, right? So, in this this particular case, the LAN is it's a /24 subnet that's allocated on it, and there are literally 4 hosts, plus the routers, but 4 hosts. Admittedly, it was an experimental LAN, but 4 hosts in this deployment. Out of those, with those 4 hosts, how many ARPs a minute do you think you might see? 10, 100, 1,000, a million? Well, it depends, sure, but with all being equal, I would expect to see very, very few. I mean, some gratuitous ARPs from time to time, and every time somebody's ARP table expires, but that's supposed to be every 4 hours by default on a lot of systems, so it shouldn't be very many at all. The infrastructure looked like this in terms of we had a pair of switches with 3 hosts hanging off them. These hosts, the switches were multi-chassis Ethernet type solution, VPC, whatever you want to call it. And we had 1 host connected to another pair of switches. Now, these were all running VARP for their forwarding, their first hop redundancy. So all routers were supposed to be forwarding. All of there was no pure layer 2 domain, it was layer 2 and layer 3 stacked on the same device. And the one sort of device that was set off on its own was this Windows 2012 host, a brand new one, that we were trying to work with. Does that strike anybody as odd? Yeah, I was a little taken aback when I saw this. I thought, well, you see something like this and you think, okay, loop. There's got to be a loop, right? I checked the logic, I went through absolutely everything. It's fairly simple. There wasn't much else could go wrong. I've lied to you and I've omitted a couple of details as to what was going on in the setup, but for all intents and purposes, I had no loop. There was no physical loop. It was reasonably complex with a couple of other switches hanging off there, but there was no justifiable reason for this. Turned out it was all a software bug at the end of the day, but and on the equipment, experimental code, we were dealing with VXLAN, we're implementing a new bleeding edge set of features, and I won't mention the vendor because they'll shout at me for explaining that they have this bug. I'm looking at it, I couldn't figure out what the hell was going on, and came in on Monday morning after the weekend after I reported it to the guys. QA found this bug where ARP messages that were supposed to be forwarded to an unlock peer to keep the VARP behavior useful, so that each of the routers within that setup knew about all of the endpoints. You have 4 switches. I draw, but my drawings are terrible. You don't want that. We have the 2 switches on the right hand side. Let's say with a single host connected off it, sends out an ARP request. The ARP request goes up to one of the switches by equal cost multipath or load balancing on the LACP connection. Hits one switch. It needs to make its peer aware of the ARP, so it forwards that across to its MLAG peer. I've given away the vendor. Then it encapsulates the ARP packet in a VXLAN header and sends it across to all of the flooded devices that are in its domain to inform its peers, so that the other guys in the network can also find it should they end up with some traffic. Because the 2 networks are stitched together. Layer 2 domains are stitched together by VXLAN in the middle. It's fairly new, I appreciate, but you'll appreciate the irony. The forwarding path wraps up this packet in VXLAN, sends it over to the other pair, and the way that works is that it gets delivered to one host. That one host is again supposed to repeat this process where that switch replicates that ARP message to its peer, so that all 4 switches now have seen this ARP packet. All 4 should know what is going on, except that the last step was supposed to be, do not re-encapsulate this in VXLAN and send it back across the flood list to where it came from, which it dutifully did, and around we go. I'm sat there on the switch looking at the ARP table and see 4 entries that are all like the age is all 0, so currently seeing traffic from this host, currently seeing ARP responses, including a privately assigned address, which is 9254, yada yada yada. There's 4 hosts. I know what all their IPs are. This isn't there. 2 DHCP addresses that the host had picked up on each of its individual NICs before bonding had occurred. Again, not in use. No idea where this is coming from. And finally, the actual IP address of the host that was suffering this particular problem and being subjected to this flooding behavior as ARPs. The complication here was that we were running a lot of security software on this device, and some of that security software was designed to pre-authorize a host for full disk encryption. So prior to boot of the host, it brings up what it knew of its network configuration from Windows, applies that, requests some authorization to actually decrypt the disk. We knew that there was some forgery going on here, there were some incredible bugs that we'd come across at earlier stages in the deployment of it. I was very suspicious of all of the security software that was installed, because I have no visibility to it, and I'm not allowed to turn it off. So it was only when I shut down the offending NIC that the MAC address was the ARP entries, were originating from that MAC address, and still continued to see the traffic. I was like, something really wrong here. That's when packet capture and identifying that the ARP tables were all full for these addresses identified that, in fact, I did really have a logical loop. Okay, just got over time, so I'll stop it there. If you've got any questions, I'll be around. Feel free to come up and ask me something. Thank you.